Welcome back. So now let's try to load the Wikipedia data into a SQL Server database, right? So I'll move to my browser, then open a new tab and search for SQL Server Docker. So let's check the results on Docker Hub. So there doesn't seem to be a Docker Compose example right here, but we can use the Docker run command to form our own Docker Compose configuration. Right, so using this, I can see there are two environment variables that were specified, right? So that's okay. Then the port mapping is defined this way. And the Docker image, where the image is going to be pulled from, is actually from Microsoft's container registry, right? So what I'm going to do is to copy this first. Then I'm going to type SQL Server DB, right? So that's the service name. Then I'll specify the image and paste the image I just copied. I'll just give this a custom password, but the password must have uppercase, lowercase, and a special character. Like, right, unlike what we did for MySQL and Postgres, where everything is lowercase for the password, right? So this password contains uppercase, lowercase, special character, and digits. First, let's do the ports mapping as well, right? So the default port for SQL Server is 1433, right? But I'll just choose 1435. Right, so let's create a volume for SQL Server first. Define volumes here. Map that volume to SQL Server database. So I'll bring up my terminal. Then I will still have the process running from the Postgres video. And here you can see the last merge query command that we ran, right? So I'll just stop this from running. And this time, let's just show how to start up a single service, right? So I'll type Docker Compose up, then specify the name of the service I'd like to start, SQL Server DB, right? So that's the only container I want to start up. So you can see the volume was created. Okay, so it seems we can now try to connect to the database, right? So I have another extension that can help us connect to SQL Server database, right? So I believe if you search the extensions, so it's actually an extension by Microsoft, right? Right, so let's just add the connection. And that's going to be localhost, 1435, then enter. The database name, I don't have a specific database created. So for authentication type, I'll select SQL login, and I'm asked for a username, base name SQL login. So I'll try SA for the username this time, and let's see if that works. Paste the password I copied before, save the password, use the same profile name, then enable trust server. Okay, so now we're able to connect to the database, right? So yeah, you want to use SA for the username, then the password is going to be what you supplied as the password right here. So let's expand the databases, and you see we have some system databases, right? And we have 4 of them. Right, so now that we know the credentials to connect to the database, I'll just create a new file here and call that SQL Server -load.ipynb. Right, so now I'll just use the other terminal here. To be able to connect to SQL Server, I'm going to install the PyODBC library. So now I'll type pip install PyODBC. Right, so now I'll import the regular libraries. So I'll run that. Okay, that works fine. Right, so to create our connection, we first have to create a connection string, right? And within the connection string, we need to define some parameters, which includes driver. So for this, I'll just specify ODBC driver 17 for SQL Server, like so. Then we need to specify the server. In this case, that's localhost, just like we saw when trying to connect using this extension. Then we need UID. That's basically the username, and that's SA in this case. We need a password. The password is actually PWD. Right, and let's get, so this is what our password looks like. Right, so let's try connecting with those 4 parameters. And so for the server, I will just specify 1435 right here. Right, that's for the ports. Then now I can use pyodbc.connect and just specify the connection string. Then run that. And that seems to be successful, right? So I'll create a cursor variable that's going to be con.cursor and run that as well. So I'm first going to type cursor, or that should be con.autocommit, and set that as true. Then run that. And using my cursor, I can type cursor.execute, and I'm going to select name from sys.databases. So we have a cursor object. So I type cursor.fetch all, and I can see a list, right? A list of all the available databases. And that's the same, list we have here, right? So what I'll do now is to create a database. I'll just run cursor.execute. Let's just create database. And let's call that, so let's call that DB. Right, so that actually works. So let's try to refresh this. So I'll just right click on databases and refresh. And I can see the DB right here. So if I expand that, and let's check the tables. Right, currently, there are no tables in that database, right? But we have a database, so let's just use that database. So executes, then use DB. So let's run that. Right, so we need a create query. So here, within this folder, SQL Server _ creates table .sql. So I'll just copy the create table for Postgres and paste that, right? So here, I'll change this to big ints, then identity, just to specify a serial value that increments by 1, right? So this is how it's done in SQL Server. And I also indicate it as the primary key. And I also indicate it as the primary key. For the country, so let's just change all the varchar to variable varchar. So I'll just add n to each varchar, so it becomes n varchar. And so for the constraints, I think this is everything we need to have. So for the constraints, it's actually going to be the same as, as that of Postgres, right? Right, so I'll go back to the SQL Server Jupyter Notebook file. Then define our create query file. And that's going to be open. We'll have SQL. Then select the SQL Server create table. So the create query itself. All right, so we have the create query right here, right? Now let's see if we can create a table using the cursor. So that's going to be cursor.execute. Then pass in create query. All right, so that didn't give any error. So let's check the database and see if we have any table. So I'm going to have to refresh that. Okay, so now we can see the university table here with the database object schema, right? So this table is within the default DBO schema for SQL Server. Right, and let's check out the columns. So we can see the columns, ID, country name, founded type, and link, right? So we have our data, and we can use SQL Alchemy, right, to create our engine, which we then pass into pandas, right? So that's going to be create engine, which we have imported from SQL Alchemy. And this is going to be MSSQL plus pi ODBC colon / then specify the creator parameter. And that's going to be lambda, then colon connection object. So I'll run that, and that doesn't give any error, right? So now let's run pd.read SQL, pass in a query. So that selects star from university. Since DBO is the default schema, I don't need to include DBO.university, right? So I'll pass in the engine, and you see we're able to run queries against the SQL Server database, right? So that's okay. So now, the way I'm going to load the data in this case will be slightly different from how I did it in the MySQL and Postgres videos. Let's read the data into a data frame first, right? So that's going to be read CSV, and we're reading universitysclean.csv, right? Okay. So now I'd like to create, a temporary table or a staging table in the database instance itself. In the case of MySQL and Postgres, right, I used the data frame as a staging table, then created tuples from that data frame and loaded, applied the merge query on that list of tuples, right? But in this case, instead of using a Python object as the staging table, I'm going to be creating the staging table in the database instance itself. Then I'll run the merge query, by applying the query on the staging table and the actual university table. Right, so let's do that right now. So I'm going to have to SQL, right? So I want to save this to to a database basically, right? So I'll start that with hash, and SQL Server will recognize this as a temporary table. So I'll just call the table staging. Then index is going to be, let's give that false. And I have to specify the connection. So I'll use the engine, right? The engine we created right here. Right, so before I run this query, I'm going to bring this same command right here. Right, and just specify hash staging. Right, so let's run that. And you see we get an error, right? The error says invalid object name hash staging. Right, so I would comment that out. So now I will run this, right? And we have a result which gives us a count of all the rows added to the staging table. So I'll run this command again. And now you can see we have some data, right? And here the last time I changed this, I changed the first two rows for the enrollment column to 0, then changed it here for each of those two columns. So we'll leave things this way, right, for now. So now I've created a staging table, and you can see I'm able to query data from the staging table, right? So I could even add, let's say, where country. So where the country is, let's choose France. So around that, so you can see we have results for France alone, right? And that's seven universities basically, right? So we can query the staging table just like any other table, but you see that, let's see if it actually appears here. So I'll just refresh that DB. But you see the staging table is not anywhere to be seen around here, right? So the table exists for as long as the session exists, right? That's the connection, the current connection that we are making use of right now. Now let's write our match query. And if you look at what we did in the case of MySQL and Postgres, right? It's totally possible to do the same thing in this case, right? So you create the tuples, then you run cursor.execute menu by putting your match query. Now, of course, your match query will have placeholders, right? That's placeholders for the tuples, right? So you can totally run the query like that, and you have the data saved into the database, right? But let's just take note that we still don't have any data in the university table, right? So if I type university here, there's still no data, right? There's only data in the staging table. So now I'm going to create the merge query for SQL Server. So I'll type SQL Server underscore offsets dot ipynb. That should be .sql actually. Right, so let's write the query for this now. So here we write merge into university, and we alias that as targets, right? Using, specify the staging table. That will serve as our source. Then on, so we need to specify the columns to match on, or the column or columns to match on. And, this combination or this column has to be unique, right? So we want to match on source. So that should be source dot, let's take a look at the source. So the staging table is the source, right? And these are the columns of the staging table. So that's on source.country equal to university, that should be targets.name, right? So remember in the table, instead of, so this should be university actually. Right, since we have university here, but in the actual table, we are using name instead of university, right? So we continue by using and source dot country equal to targets dot country, right? So for the source, the country starts with uppercase, but for the target, it starts with lowercase, right? So I'll continue by typing when matched, then, so I'd like to update. So when matched, then updates, sets, right? So let's look at Postgres merge query. So I'll just copy this, then paste. So here I'll hold Alt down, right? Just after excluded. Then instead of excluded, I'll just have source dot. So if we check the source table, we have founded, right, with capital F. We have type with capital T, we have enrollment with capital E, and we have link with capital L. Right, so I'll just hold Alt down again. Then we should have target dot right here. Right, so target dot founded will be assigned the value of source dot founded, target dot type, source dot type, target dot enrollment, source dot enrollment, and so on. So that's for when we have a match. Right, so I won't terminate this query yet. So now we have when not matched. Then so what we want to do in that case is to insert, and we specify the columns that we'd like to insert, right? So I'll go back to the Postgres offsets. So these are columns I'd like to insert. Then I specify values. So the values will be similar, but they'll be from the source. So here I'll have source dot country with capital C. Then here source dot university as the name. Source dot founded as founded. Source dot type as the type. Source dot enrollment, that's for this enrollment. And finally source dot link. So now I can terminate the query. Right, so now let's go back to the Jupyter notebook and let's see if we're able to run this query. So first thing we need to do is to create merge query file, and that's going to be open. That's SQL. And let's look for SQL Server of SAT. Then the merge query itself. Right, so here is the merge query for SQL Server, right? So now I don't need to use cursor.execute menu, right? Because I'm not passing in any data from the Python environment. The merge query will be between the staging table, which is already available in the database instance, and also the actual table, right? So I'll just run cursor.execute merge query, and let's run that. And now we can see that that was actually successful. I guess the only way to check is to run this query again, right, to see if we have some data. So I'll run that, and sure enough, we have data available in the database, right? So what I'm going to do now is, so let's scroll up to the part where we loaded the data. Okay, so I'm going to run things from here now to see if we can actually update to see if the table gets updated when we update the file. So I'll look for universities clean. So I'll change this back to their original values, right then. So I'll search for France. And the first value we have here, so this is 60,000. I'll change that to 1. Then the next France, 70,000. I'll change that to 2. Then let's look for the next France and change that to 3. Then let's look for another one. Change that to 4. Then this to 5. Then to 6, right? Okay, so now let's run the query again to see if the values actually get updated. So I'm going to run things from here. Then I expect these values to be 1, 2, 3, 4, 5, 6, and 7, depending on all the things we added here. Basically 1 to 6, right? But I'm sure there's one or two rows that we missed. But I'm sure there are maybe one or two rows that we missed. So I'm going to run this from here, right? So execute cell and below. And if I run that, okay, so it says this staging table already exists. All right, so what I can just do is to run everything from the beginning, right? So I'll restart the kernel and just run all. Right, so once a new session is established, the previous staging table would have been cleared, and we'll be able to create a new staging table. So there seems to be an error somewhere. Okay, right. So this database already exists. I'll comment this out, then run all from the beginning again. So let's run all. All right. All right, so I have to comment out some of these queries. Right, so I'll run on again. This is just to make sure that the upstart query works as expected. All right, I think we created the staging table after this. So I'll just copy this, then just paste it here. Right, then I'll just run all from the beginning again, and hopefully everything runs smoothly this time. All right, so you can see, these values were loaded from the CSV file, right? And we had these values in the database already, right? Before we ran the O query again. But now we loaded the upstart query, and we just executed the query here. Right, so let's see if these values would have been updated. These values that exist in the database, right? Before we run the code again. So I'll just copy the same line, right? And by now, these values should have been updated with their initial values, or the original values we scraped from the websites. So I'm going to paste this right here, then run. And we can see the values have actually been updated, right? So these are the actual values: 1992, 209, 7182. And here we have 2013, 0, 2023, 0. Right, so we've been able to successfully load the data we scraped into a SQL Server database, right? So you can see the similarities, between these different drivers for interacting with different databases, right? So that's going to be it for this video. I hope you have really gained a lot from this project, right? So this is a project that can be extended, right? So we can add, more videos on how to add data to other databases like MongoDB, Elasticsearch, and so on. So thank you very much, and I hope you have really gained a lot from this video and this project in general. So see you in another project.